Okay, so today we're going to get into something called conditional probability. I already introduced you to this a little bit yesterday and in the day before. When you hear conditional probability, look for that word given. So the biggest difference is that instead of your probability being out of the total number of people who were surveyed, now it's going to be out of the total for a particular row or column. So let's recap actually creating a two-way table. And actually, if you notice, look at the probabilities in this situation. 0.62, 0.43, 0.38, they're only to the hundredths place. So I'm actually going to tell you to change this to be a 100 sample two-way table. Okay, so you didn't really interview 100 people, but you're going to pretend like you did interview 100 people, and this is going to tell you what portion of the people actually satisfy this situation. Okay, so if you remember, when you do this two-way table, the column all the way on the right-hand side and the row all the way on the bottom, those are your totals. We're interviewing a theoretical 100 people. If it says, and we're talking about things that have a king-size bed and a view of the town square. Okay, so either I have a king-size bed or I don't have a king-size bed. I have a view of the town square, or I don't have a view of the town square. Okay, and again, it doesn't matter if you put the V's on the top and the K's down the side, all the probabilities will still work out to be the same. And remember, all of the rows and columns should add up to their respective total. So if it said 60, the chances that I have a king-size bed is 0.62. That means that 62 out of my theoretical 100 people had a king-size bed in their room. Okay, if it says that the probability that the room has a view of the town square is 0.43, it means 43 out of our theoretical 100 rooms had a view of the town square. It says now also that the probability that someone has a king-size bed and a view of the town square is 0.38, so 38 people had both a view and a king-size bed. Now, like I said before, once you have, something in the totals column and something in these middle four boxes, now you can just spend the rest of the time adding and subtracting to fill in all the rest of the values. Okay, so if I think of doing 100 minus 43, I can get 57 for the total without a view. 100 minus 62 would be 38 that don't have a king-size bed. 43 minus 38 would be 5 people don't have a king-size bed but have a view. That means 33 here, and then finally 24 for that last space. So you just make sure everything adds and subtracts together. And honestly, once the two-way table is set up, then you can just literally pull the correct, box out of the total and get your probability. I want to give you the advantage of a two-way table over the Venn diagram, even though it's all the same stuff. If you remember, this was the overlap on the Venn diagram, this was the space outside the circles, and these were the spaces in the circles without the overlap. It's all the same information, it's just presented differently. But again, a two-way table has a space for everything. You don't have to hold on a piece of information so that you can, combine it with another piece. And once you start filling in any of those information, any of those rows and columns, everything kind of falls into place. So what's the probability that a randomly selected room will have a view of the town square or a king-size bed? Remember that when you set up your two-way table like this, the or is these three boxes added together. Everyone that has a king-size bed with no view, everybody that has a king-size bed and a view, everybody that has a view but not a king-size bed. Okay, so that's your or probability. So when I add those together, 24 plus 38 plus 5 out of 100, it tells you that it comes out to be 67 out of 100, or 0.67 is the probability that somebody has a view of the town square or a king-size bed. So this is where we start getting into those conditional probabilities. If a given room has a king-size bed, that means your probability is only going to be out of the rooms that have a king-size bed. So only this column right here. So out of these 62 rooms, not out of all of them, just the ones with a king-size bed, what are the chances that they have a view of the town square? 38 of those 62 rooms had a view of the town square. You can see that if I turn this to a decimal, 0.613, there's a pretty strong likelihood that if I have a room with a king-size bed, I'm going to have a view of the town square. Okay, so again, based on what it says after the word given, you focus on just an individual row or column, and then you do your probability out of just that, the information in that row or column. That's what we refer to as conditional probability. So you can see the official formula below, the probability of A given B. Okay, so this is your given thing, whatever it happens to be. In this case, it was a king-size bed. I would say, okay, out of those king-size bed, I'm going to take the overlap and I'm going to divide it by the chances of having a king-size bed. That's basically what's happening here. But again, I like to look at it more in terms of what's the total in that column, how many in the overlap, and then as I make those into a fraction, that gives me my probability. Okay, so using the information from the do now, calculate the probability of, so this is probability of K given V. Okay, so that's what this bar means. This means given. So when you do this whole given thing, that means you're going to focus on just that row or column. So let me go back up here for a second. I should probably erase some of these things. Get rid of that. Okay, I only want to focus on the V row or column. Okay, so the V row or column is this one right here. There are 43 rooms then that I'm focusing on in this situation. So out of those 43 rooms, how many have a king-size bed? 38 of them had a king-size bed. Okay, so 38 out of 43 comes out to be 0.884. So once again, you can see a very strong connection between having a king-size bed and a view of the town square. Again, we're not really at the point of drawing inferences, but why would someone want to know this information? Well, if you're going to start like making a hotel with king-size beds or views of the town square, you can see there's a big connection between those two. Maybe you can use this kind of information to draw inferences. That's the idea of what happens with probability and statistics. So let's, before we, instead of making a table for just a second, let's just do a little bit of practice with, these two-way tables and answering some of these probabilities. Okay, so it says right here, what are the chances that out of these graduating seniors that I choose someone who is male? Okay, so right now these are not given probabilities. I only get to given when I see this bar thing right here. What are the chances that I pick somebody that is male? Okay, so that is 30 individuals out of the total 52 that I ended up having out of everyone. So this total is out of 52 right now. If you remember the U is or, what are the chances of picking someone who is male or female? Well, in this case, that is actually everybody. There's 30 plus 22 divided by 52. There's no overlap between male or female. It was just 30 plus 22. So it was actually a definitive thing. There's this disjoint. There's the reason why this is disjoint. There's no overlap. Probability of picking someone who is female and going to college. Okay, so female and going to college, that is 13 out of those 52. Now let's get into some of those given probabilities. So with these given probabilities, you focus on a specific row or column. So this is saying, what's the chances that I pick a male given I'm selecting from the students who are going to college? Okay, so you're given C, which means you focus only on that particular row or column. So out of those 29 individuals, how many are male? 16 out of the 29. You'll notice that it changes if I change my given. So look at E. In E, the difference is that I'm given male students, not given students going to college. So now I'm going to focus on this specific column. The total in that column is 30. How many of these 30 students are going to college? 16, and you can see they come out to be totally different calculations. So again, focus on what comes after the word given. Focus on that particular row or column, get the total in that row or column, that's the denominator in your probability, and then, whatever thing that they're asking you to satisfy, that would go in the top. So let's make up I'm not going to make a Venn diagram because like I said, the two-way table is going to be better. I'm also going to edit this to be a 100 sample two-way table because we're dealing with percents. Okay, so again, based on if you're dealing with percents, that's out of 100. So that's why probably a theoretical 100 people is going to be a little bit easier. So I'm going to make my two-way table like we did yesterday. You want to put 3 rows down. You want to put 3 rows across. Totally on the total goes on the right hand side and the total goes on the bottom with nothing going in the top left hand corner. You're talking about long-term card holders and people who are not long-term card holders. You're talking about people who pay their bill in full every month and people who don't pay their bill in full every month. And now we're going to go through and we're going to fill in all this given information. And again, the benefit of the two-way table, there's a space for everything, okay? So it says that 42% are long-term card holders. So 42 out of our theoretical 100 people long-term card holders. That means that 58 are not long-term card holders. 35% pay their bills in full every month. So 35 of our theoretical 100 people pay their bill in full. So 65 do not. 23 are long-term cardholders who also pay their bill in full every month. So 23 satisfy both L and F. So now I'm just going to go through and I'm, going to add, subtract, whatever to fill in the rest of the information that's left in this particular situation. So if I do 42 minus 23, that would be 19. And if I do 65 minus 19, that would be 46. And then finally 12. And now I filled in all of this information. Again, that's probably the hardest part, is making the two-way table. Now we get to, draw more conclusions and do some calculations from this. So it says calculate P of F given L. So given L means you're focusing just on that L column or row. So the total in that would be 42 people. So out of these 42 long-term cardholders, what are the chances they pay their bill in full every month? 23 out of those 42, which comes out to be about a value of 0.548. As opposed to just the chances of someone paying their bill in full every month. The chance that someone paid their bill in full every month was 35%, so 0.35. So you can see there's a greater chance that someone's going to pay their bill in full every month if they're a long-term cardholder as opposed to if they're just somebody in general. That's the conclusion we can draw from this. Okay, long-term cardholders more likely to pay their bill in full a month. Pay their bill in full. Okay, and again, why would you want to know this? If you're a credit card company, maybe that's some way that you can charge fees or, again, draw conclusions about the people who are your customers, something like that. Okay, one more example, and then we'll stop. When a car is brought to a repair service, the probability that the transmission fluid needs to be replaced, and there's all this stuff with brake pads and all that kind of stuff. So they're saying let transmission fluid be T and brake pads be B. Okay, again, I'm going to skip the Venn diagram because the two-way table is going to be better, and I'm going to again switch to a 100 sample table because my decimals are to the nearest hundredth. Okay, so I'm going to take that information and put it in a two-way table. So when I set this up, I'm doing 3 rows down, 3 rows across. Okay, so I'm going to have the totals on the far right and in the bottom. I'm going to have B and not B, T and not T. And again, it honestly does not matter where you put your B's and your T's. You could reverse them if you want. We're talking about a theoretical 100 people. So it says the probability you need a transmission fluid replace, that's 38% or 0.38 or 38 of our 100 hypothetical people need transmission fluid. So therefore I would have 62 that don't need transmission fluid. I have 28 that need brake pads. So that would mean that I have 72 that don't need brake pads. And then it says that I have, what are the chances I need transmission fluid and brake pads? That's 16 people. And then I can just go through and add and subtract until I fill in all the other values that are left in this table. Okay, so what's the chances that I need brake pads given that I needed a transmission fluid change? So given T means focus only on that T row or column. There are 38 people in that row or column, okay? How many of them need brake pads? Of those 38, it would be 16. That's the probability of needing brake pads given we needed transmission fluid. Okay, so let me just erase that. Oops. Hopefully I can do it. Oh, good enough. Okay, so now if you look at the next one, this one switches. This one is saying I need transmission fluid given I needed brake pads. So now I'm going to focus on that B column, okay? The total in that column is 28. How many people needed transmission fluid of those 28? 16 of those 28. So 16 of those 28. So you can see it's a different calculation because you're focusing on a different row or column. This one says, what's the chances that I need brake pads and transmission fluid? So notice how these are no longer given probabilities. This means that your probabilities now go back to being out of 100. You're not focusing on a specific row or column. So B and T, okay, things that satisfy both B and T, that would be 16 out of 100. And this one says B or T. Remember, or is these 3 boxes added together. Everyone who needs brake pads or transmission fluid, regardless of if they need both. So that would be 12 plus 16 plus 22, And again, that's out of 100 because that's no longer a given probability. Okay, so I think these examples should be enough. Just remember, focus on the word given. The word given tells you the specific row or column to focus on. Your denominator is now the total for that row or column. And then again, you choose whatever the required